Well, hello again. This is our continuing our study in chapter 1. We're going to be looking at 1.2 linear equations with one variable. Now, some of these problems aren't going to look linear. However, they are linear because there's only going to be the answer is going to come out linear, or the problem itself. All right, so let's take a look at the first idea that we want to cover. And this idea is the difference between a conditional statement versus an identity. A conditional statement means it works for a single case or some cases, whereas an identity means it works for every case. So let's get an example here. And the actual definition. A conditional equation is an equation that is true for only some or none of the real numbers in the domain. Like this: x squared minus 9 equals 0 only works for when x equals negative 3 and positive 3. So it's conditional. It only works if x is negative 3 or positive 3. So this would be called a conditional equation. Likewise, this one here is 2x minus 4 equals 2x plus 7. If I subtracted 2x from both sides, my 2x's would cancel, and I'd get negative 4 equals positive 7, and that's not true for any value. So this is not true for any real value of x, and therefore it is also a conditional equation. But we do have equations that can come out as identities, means it's always true, and that would be something like this: x squared minus 9 is equal to x plus 3x minus 3. If you were to FOIL the right-hand side, this x plus 3x minus 3, you would get x squared minus 9, and that is a true statement always. This is always true. X squared minus 9 is always equal to x squared minus 9. So something like this would be an identity, or something that looks like this. If you were to simplify this statement, on the left-hand side, you distribute the 3x, and you get 3x squared minus 3x plus 4. That is equal to 3x squared minus 3x plus 4, and therefore those two things are equal. It's an identity. All right, this is a pretty straightforward thing. Usually when we're solving equations, most of them are going to come out as conditional. However, every once in a while you can have ones that come out as identities. All right, let's look at solving equations. So that's really what our goal is today, for the most part, is to solve equations where x is our only variable, or y is we only have a single variable, whatever variable they choose to use. I am going to start off with fractions because most of us can solve 3x plus 2 equals 7. I think we can all solve that. But we have a little bit harder time when it's 1/3 x plus 1/2 equals 1/7. We get a little bit struggling here. Or if it's something like 1 over x plus 2 plus 1 over x minus 2 equals 7. That is a little bit more challenging of a problem. But the thing we need to get, notice it's in all caps, is to always multiply by the LCD, the least common denominator. This is very important for us to divide or multiply both sides of the equation by the least common denominator. By multiplying by that LCD, you're going to cancel out all fractions, and it will create a much easier problem to solve. So I'm going to write up some examples here, basically straight out of the textbook. And let's just start with an easier, let's go and do 1/3 x plus 1/2 equals 7. And it's a little bit more easy, but let's try something like this. My least common denominator is going to be 3 times 2, which is 6. And so I put it around the entire equation, making me understand that I have to distribute to all three pieces here. And when I distribute, this becomes a 2. 6 times 1/3 is 2. 6 times a half is 3. And 6 times 7 is 42. And notice this is a much, much simpler equation to solve than the original one. I can subtract 3 and divide by 2. And I would have a much simpler answer. But what if it looked like this? Let's go with a 10 minus 13 over x equals 4 plus 5 over x. Now, you can solve this without doing LCD, but it's so much easier to do it with the LCD. The only denominator is x, and that is my lowest common denominator. So again, I'm going to take this x and I'm going to distribute to all 4 of these pieces inside this set of brackets or parentheses. So my first one is 10 times x, which is 10x. The next one is I'm dividing by x here and multiplying by x. Therefore, they cancel. I'm left with a minus 13. Here I get times the 4. And lastly, multiplying by x here, they cancel. And I'm left with 5. And once again, this is a much simpler problem. Subtract 4 from both sides. Add 13 to both sides. Divide by 6. Oops, I don't know where that came from. That's not right. How about a 3? And what I think I have, I don't have answer written there yet. Shoot, I just erased it. That answer should be x equals 3. Make sure you check your work. Obviously, 3 is going to work in that one. We could look at something like x over x plus 4 plus 4 over x plus 4 plus 2 equals 0. And what we want to do is, now this isn't the only way to do this, but what I want to kind of keep this habit is multiplying by that common denominator, which is x plus 4 and x plus 4, so it's just x plus 4. So here, multiplying this to the first one, it cancels, and it leaves me with an x. Multiplying to the second one, it also cancels and leaves me with a 4. Multiplying to the third one gets a 2 times x plus 4. And multiplying by the last one gets me just 0 because it's 0 times x plus 4. So I get x plus 4 plus 2 times x plus 2 times 4 equals 0. I'm going to move myself right over here. X plus 2x is 3x plus 12 equals 0. If I subtract 12 and divide by 3, I get negative 4. So remember, the biggest thing that we need to understand here is when we get to these fraction problems, multiply by that common denominator. And we're going to have lots of these, and there's going to be more challenging ones later when we get out of the linear pieces and into like quadratics and cubics and stuff like that. All right, let's see if I have another example here for us. What about, I'm going to erase this stuff here. Last one before we move forward. What about x over 5 minus x over 2 equals 3 plus 3x over 10. So again, I'm gonna stress this again. We need to understand how to do this for the simple problems, so that way when the harder problems come up, we already know how to do the basic process. So here I have 5, 2, and 10. Well, it just so happens that the common multiple is 10 for all of those. If I multiply by that first one, I'm going to get 10 divided by 5, which is 2. So the 5 cancels, leaves a 2 times the x. Here to the second one, the 2 cancels with the 10 to make it a 5, so I get a 5 times the x. I'm going to come right here and I'm going to say 10 times 3, which is 30, plus the 10 times the other fraction there, the 10's cancel, I'm left with a 3x. So now I'm just simplifying. If I subtract 3x from both sides, I get a negative 6x equals, not 60, 30. Divide by negative 6, I get x is negative 5. All right, let's go ahead and move forward. We are actually almost done. This one's going to be a very short video for you guys. The last piece that I really want to stress for you guys is this. Check your answers. Even if you do it just in your head, the biggest thing that comes up is sometimes you get an answer, but that answer doesn't work. So let's say you get something like 1 over x plus 4 plus 7 equals 3. Now this is not the answer to this problem. If it is, I'd be shocked. Let's say you do all of your work and you get down to x equals negative 4 and you just box your answer and you move on. Well, if this was on a quiz or a test, I would have to say you're wrong. Because if I plugged in negative 4 into this equation, that would make a 0 in the denominator and therefore it would be wrong. I cannot divide by 0. So this would actually be extraneous. And I just basically look at the word extra in this statement. It's an extra answer. Extraneous x equals negative 4. So this would actually have no solution because the only answer that I get can't work. All right, so make sure you understand that. Here is your assignment. It's a little bit lengthy, not as lengthy as it might look. Have fun. I will see you guys tomorrow.